Sir, good afternoon, sir.
Good afternoon. Good afternoon.
Nag ako
Kanyo,
yung istorya ninyo, sir, ba?
unsa man?
Yung arang pag guman sa klase, sir, kanang out na sila.
Ah,
Sir, na ako'y pangutana unta sir.
unsa man?
Regarding sa sir ba sa kaning sa amuang OJT sir, then na-assign mi sa imuha nga ikaw nga instructor sir, mo ask lang unta ko sir if nabay other way
Wala
para
pa ko. Wala pa ko ikuan. Ihatag nga assignment.
wala pa kay task ihatag sir.
Wala pa. Basig mangutana ra ko sa uban tingali nga kuan. Ang mga maestra.
Mo ask lang tayo sir if naaba ka sa school within Thursday or Tuesday sir.
Dili ko kasiguro kay kuan manggod lain man akong kuan na may mga times nga moadto ko sa MC1. Most of the time kanang wa ko'y klase.
Ah.
Oh.
Pwede makapangayog contact nimo sir as kanang makapangutana mig naaba ka sa nurse sir ba or unsa or
Sige.
email sir.
Oh, sa email. Wala mo kasulay og email nako.
Mo email lang ni sir.
Oh, sige. Ako rang ikuan akong email address sa kuan sa atong kining classroom.
Sige sir, thank you sir.
Kana pod inyong mga kuan, kanang inyong mga post sa classroom, Google Classroom, makita pod nako na sa kuan sa akong email. Kaya automatic man na siyang i-post kuan dito email. So, ug mo post mo, makita ra gyapon sa akong email. Sa atong classroom, Google Classroom ba?
Mo email lang ni sir if maayo mig test sir.
Ako di pa ko kabalo ug unsay ako ipatrabaho ninyo.
Sige sir, thank you sir.
Hey. Mangutana pa ko aning ubang mga mga maestro nato.
Ay pero mangutana mo kuan ra unta mi sir if what day ka naa diya mga next week sir kay na lang unta pud may pangutana regarding sa among project pud sir ba. Para may question nga ipang ask sa sir if ever nga wala pay task.
Dili pa ko ka siguro gyud kay ang akong status manggod ipatawag ra ko anytime dito sa MC1. Yeah, usually kuan kanang ganiha para sa ganiha ni adto kog MC1. Yeah, usually ang ilang kuan na is either Tuesday or Thursday. Pero naay emergency nga naipapirmahan dito so I have to go to MC1 ana ba? So
Okay.
mukuan ra ko og kanang siguro gyud ko nga wala ko'y lingaw. Nga naa ako dire ba sa MC2. Okay? So, okay na tingali ta. Can you turn on your cameras so that we can document our class this afternoon?
Excuse me, sir.
Ah,
Na-contact na rin ako si Engineer
Si
Engineer Infante, sir.
niya unsa may kuan.
Sir, kag na pag ko naka-contact kay atong na mga naging adlaw line busy or usay mo beep. So,
Oh.
kuadra, basig sa akong signal. So, kung buntag niadto ko sa downtown para mutawag para ko sureball nga ako signal. And then, ingon din siya nga, na-set na rin daon tato katong Wednesday sa inyong meeting. Wednesday may padtuhon. Kay ang ako sa ginang nga sa ko pong signal di wa din ko ka contact ko niya. Yan na siya next week Wednesday na lang mupasa mi og kanang sets of officers kanang official
Okay,
na mo.
sige.
Then
Sige.
magpapirma minimo kay para ato pong sa advisor. And then mupasa po mi og kanang pinaka outline sa mong mga activities nga ikuan karong year.
Sige.
And then mga po din sila contact number po din nimo, sir.
Wala di ay.
Ano sila.
Sige.
Yes, sir. Thank you, sir.
Sige, turn on your cameras, please. So we can start our class. The cameras on, please. Okay, class, are we ready? Can you see the board?
Yes, sir.
Class, okay. So, can you see me now?
Yes, sir.
Okay, good. This afternoon, we will be discussing a new topic, which is a very useful tool in analyzing stresses. No? If you will recall, we discussed stresses, and the stress were just simple, meaning only in one direction. Okay, and we also are on an experiment class hybrid. Is this hybrid? Or because we have those who are having an OJT here for humanitarian reasons, I did not ask them to go and let them stay in class, no? So nasa sila sa classroom karon, and then because there are only very few, so kaysa they are having their OJT until 12 o'clock, so maglisod sila pa uli. So I'm just considering mo attend na sila sa classroom, okay? So but this is on a very occasional basis ra, no? Dili po ni permanente kay I'm sure nga dili kita maigo diri if I'm going to let everybody come in. Okay? So again, the Moore circle is a graphical solution to combined stress problem. Now, combined stress problem is that when, by the way, I will introduce you to an element. Okay? How do we analyze a certain portion of the member or the element and represent it graphically. Okay. This is how we represent it. Okay. In other words, you picture or you imagine a member. So probably a member like this. And then you have different stresses all throughout. And then you pick a certain smallest particle you can imagine and then analyze the stresses on that particle, which we call element. It is a square. And then, of course, the sides are the stress area where your stresses are acting. Okay, so you have four sides. So like this one, if you look at the element, it will be something like this. I'll just magnify it. It will be something like this. You have this one will cause a stress this way, that way, and this one. Okay. Okay, so that is a combined stress situation, no? Combined stress. Now, we are going to concentrate on this element first. Now, we will understand what is this element. Okay, so you have your x and y axis. Of course, along the x axis are the stresses acting. This could be tensile, or if you reverse the direction, it could be compressive. Okay? And then as you will recall, we have placed a sign, no? Meaning tensile are positive and compressive are negative. No, like compressive dire puros tensile. This is in the direction of y, or the y axis, no? Okay, sigma x and sigma y. These are the normal. By the way, sigma stands for normal. And this is, sorry, wala na akong butang yung tau xy. Okay, and these are the normal stresses. Now, if we look at a certain problem, let us say, under shearing, okay. So, can you see my illustration?
Sir.
Makita, oh, dera. Okay. This is, if you consider an element on that sheared portion or the stress area, then, wag man tayo space lain, ako ning i-reason, the element will look like this. Ayun, ito dito, no? So, ana. Okay? These are the stress, shearing stress represented, no, on the element. Now, if you try to recall, for static equilibrium, along the x direction, this sigma x should be equal to this one, so that it will cancel out. So the summation forces along the x will be equal to 0, and this sigma y should be equal to that one. So automatic na. Now, even if I did not place sigma y here, this is the same magnitude at the sigma y, and this is the same magnitude as sigma x. However, the shearing stress, if you consider only this one as what I have illustrated earlier, na ay shearing atong kuan, it is only here. This will not be in static equilibrium, because if you take moments, now it will turn clockwise. Okay? So, to make it into a static equilibrium, we have to place a couple here. And this shearing stress should be equal to the shearing stress, so that this will be in static equilibrium. Okay? Now, of course, there is no problem when there is no shearing stress. No, kung mawala yung shearing stress, there is no problem. Dili ra na nato butangan. However, once there is a shearing stress in any direction, the other side of the square should have also a shearing stress. So this is the element, no? The element. The smallest particle in the member that you can imagine is called the element. Okay. So natay shearing stress dire. Normal stress tensile, sigma man ang normal stress. Tau xy is the shearing stress along all the sides, no? All the sides now. Because again, to establish static equilibrium, then tau xy should occur on all the sides of the square. And then you use sigma y. Okay. So that is what is called the state of the element. No? Given state of the stress of the element, you have your stresses on the x direction, normal stresses on the x direction, you have your normal stresses on the y direction, and your shearing stress along the x direction is this one, kini. And your shearing stress along the y direction is this one, kini. Kaning kauban sa y. Again, no? So you will notice tau xy represents the magnitude of all these shearing stresses. Okay, but again, the direction is this one should be opposed with this one, and this shearing stress should be opposed with that one. If you will also see the PDF file, probably this one is a complete arrow, no? Anak good siya. So, but I am using this half arrow anyway just to indicate, because it will, if you draw it, it will touch the square, no? But anyway, the direction is given. Okay, so sometimes ana ang pag-drawing sa uban nga authors, no? Full arrow. Okay. So ako rang kuaning sa ubos kay aron limpyo, no? Kaning sa ubos nga iyang kuan. So ana ra akong arrow. Okay. So again, that is the state of stress of an element. This is complete on all sides of the square. You have normal stress and shearing stresses. Okay, so in certain cases, maybe only one is present, no? Not necessarily, not always every time. Ang stress in all the sides is present. Okay, so since you now have an element, again, let's look at how we set up the Moore circle. Again, it is a graphical solution to combined stress problems. Okay, now, if, for example, you have your, let's just say a simple stress on this member. And then, what happens is that this member will fail not in this direction, but at a certain direction, like that. So what are the stresses involved during the failure? Because if you say this alone is the one that is causing it to fail, now you only have two kinds of stresses. You have normal stress and you have shearing stress. So what will happen? Your stress should also be acting normal or in this direction for shearing. And this is not consistent with that direction. However, we can take the components of this Okay? So in other words, instead of this one, we resolve it into its components. Yan eh. Okay? So wala na to ha. Mauna ni siya. This is now the equivalent of those. And kani po siya, we now have this one and that one. These are the component of this. And you will notice that this is now consistent with the direction of the failure, where this one is normal, which is tensile to the element here, and this is shearing. No shearing is here because it will slide the member that way and this way. Is my illustration clear? Akong drawing? Klaro ra ba? Okay, even if we started with only a simple normal stress, but it depends on the orientation of how the member fails or the element fails, no? If it failed in that direction, of course, wala ra na ra. However, if it failed at a certain orientation, then it has a shearing stress, this one and this one. And it has also a tensile stress. And of course, since that is present, there should be, for static equilibrium na gina siya, pares diha. Okay. So that is combined stress. Even if you started with just a simple normal or tensile stress, if you try to look at a different orientation, you will have different stresses on the element. Okay? So we will illustrate that later, no? So that is combined stress. Again, sigma indicates or designates, as normal stress is designated with sigma, and shearing stress is designated with tau. And normal and shear stress at a point in the body, this point is where we represent this point is represented by the element, no, katong square. This point in the body becomes the coordinates of a point on the circle. So since it's a more circle, it is a point in the circle. No, we are going to draw a circle, and then the angles in the element is doubled in the more circle. Okay, and we will understand this later, no? Maximum and minimum values of normal stress are called principal stress. Okay? So ang maximum normal and maximum normal stresses, it could be tensile, it could be compressive, are called principal stress. So, to establish or draw the Mohr circle, we have a Cartesian coordinate. No? A Cartesian coordinate, this is the origin, meaning on this direction, on the vertical direction, is your shearing stress, and on the horizontal direction is your normal stress. No? Now, on the right side is positive, so you will have your tension. And on the left side is negative normal stress, which is compression. Now, for shearing stress, our signs, we do not place negative or positive for our signs, because what the shearing stress does to an element is to rotate it either clockwise or counterclockwise. So we plot the value of your shearing stress at a certain axis upwards, no? Upwards if it tends to rotate the element clockwise, and we draw the point of the element downwards if the shearing stress tends to rotate the element counterclockwise. Okay? So I will expound that, or we will have an example. Okay? So remember, this is plotting, no? Plotting values in your Cartesian coordinate. So for example, naka-value nga sigma, how much is that? So you start from the origin up to that. That is the amount of sigma. So pila na siya ka PSI or pila na ka megapascals. Then for shearing stress, if it tends to rotate it clockwise, then you plot it upwards. If it tends to rotate it counterclockwise, you plot it downwards. Okay. So, going back to the element. Okay, let's go back to the element. So, given state of stress of an element, you have sigma x and sigma y. Sigma x is greater than sigma y and tau xy. How do we plot that on the Mohr circle? Okay, so let us say, how much is sigma x? So this is our Cartesian coordinate. The origin is here. So from here until okay, from here until here, that is sigma x. But it is already indicated here, no? If you try to recall, the first is on the, no? Kanang sa inyong coordinate system. Kadumdum mo niyo sa coordinate system ninyo. Ngayon ka nga, A, 2, 3. Meaning, 2 is x, and 3 is y. Ug ma-negative na siya, of course, negative x. However, in our case, ang sunod ani is the shearing stress. We do not have a negative or positive, no? Okay, so it is already indicated here. Sigma x is from the origin to, no? Kini siya ang sigma x. How about sigma y? Sigma x, let's assume nga nano tayo value sa sigma x. We will plot it here. How about sigma y? We represent sigma y to be a smaller value. Okay, asa man tong opposite sa sigma x, na dere, sigma y. That is your sigma y. Of course, it is already indicated here, sigma y and tau xy. You will notice that the tau here on the x, by the way, sorry, you will notice that this axis here is x-axis, and this axis here is y-axis. Now, you might ask, why is it that the x and the y-axis are in line? Well, in fact, in our Cartesian coordinate, the x and y-axis are perpendicular, no? X and y. But in here, they are in the same line. Okay. I'll go back to the first. It says here, the angles in the element is doubled in the Mohr circle. So meaning, if our x-axis to the y-axis is 90 degrees, in the Mohr circle, it is doubled. So, pila na? Huh?
80.
So, 180 na. So, that is how we represent the axis, These are now the opposite axis. So, this is sigma x, axis x, that one, and axis y is this one. Walang ning ko anon. Laroho ni. So it is Sigma x is from the origin. From the origin, no? Muna siya, sigma x. Ang sigma y nemo is also kana. Di ka na siya diri ha? So again, we have to have values. No? We have to have values for these stresses so that we can plot it on the Cartesian coordinate for the Mohr circle. Okay. So you have here the x-axis and the y-axis. Now let's go look at tau xy. Now tau xy for the x-axis, again, tau xy are the shearing stress around, no, around the element. Now for the x-axis, it is this one and that one. These are the shearing stress for the x-axis. And what is the direction? What direction it tends to rotate?
Excuse me, sir.
Sir, mo camera, sir.
Camera, sir. Camera, sir.
Sorry. Okay. Sige. I'll go to repeat it, no? Okay na ta sa sigma x and sigma y. Okay? Sigma x is in the x direction and sigma y is in the y direction. Now, and then we plot how much is sigma x? We plot it here. So that is the amount, that pilay value ana sigma x. And sigma y is, that is the value of sigma y. Next, how about the shearing stress, tau xy? Now, tau xy, the shearing stress tau xy, in the x direction is this one and this one. No, these two. And what does it tend to rotate your element? In what direction? Huh? Siga, kaya alam makadungog sila. Did you hear that? Nakadungog mo? Okay. So clockwise. Meaning, if we are going to plot it in the coordinate system, this is your sigma x, and clockwise is where? In what direction? In the... Huh? It is going upwards. So, kini siya imong tau xy for the x direction. Na siya, that amount is the tau xy. Now, if you go in the y direction, it tends to rotate it counterclockwise. So, you have to plot it downwards. Now, this tau xy and that tau xy have the same magnitude, no? Kini sila. These two, all these tau xy have the same magnitude. And if you where point A represents the stresses on the x direction, and point B represents the stresses on the y direction. Okay, and then you connect it, and then you draw a circle that is now the Mohr circle. Okay, Mohr circle. So far, any question? Make sure you understand that. Make sure you understand how we plot. Any question? Any question? No questions? Okay. So, now, again, the angles in the, so you will notice that the angle in the Mohr circle is doubled than the angle in the element. Okay. Now, if we tend to rotate it at a certain direction, like this one, okay, muna na siya, original orientation of the element in the x and y. Let us try to evaluate what are the stresses when the element is oriented at a certain angle phi from the original axis X, and of course, original axis Y. No? We'll call this axis U, and we call this axis V, and we'll call the shearing stress around it as tau UV, and then sigma U and sigma B are the normal stresses along the V and correspondingly along the V and the U direction. Okay? Now, how do we plot that in the Moore circle? Okay. So, we plot that based on the orientation. According to your element from X, it is phi downwards. So, remember, this is our x-axis. This is our x-axis. So, if we try to plot that, this is your double phi. No? 2 phi from here and from there. And this will be your u-axis, this one. It is phi here, but it is double phi in the Moore circle. That is your u-axis. This time, this is our u-axis. And our v-axis is, of course, opposite to the u-axis, no? Because it is 180 degrees apart, double in the element. And the stresses on your element. Let us say our normal stress, which is still tensile, is sigma u on the u-axis or the u direction. And our normal stress on the v-axis or the v direction is sigma v. And then your shearing stress is tau uv. You will notice that the values of sigma u is here. No, so ano na siya dire? Ha? Kana. That one is sigma u. And sigma v is this one. Now let's check the tau uv. Now we have rotated this 2 phi, meaning on the u-axis, no, in the u-axis, the shearing stress should tend to rotate the element what? Okay, naaman dire siya. In what direction? Kining tau uv. Kining nga tau uv for point B. Naaman siya dire. It is
Clockwise, sir.
Clockwise, okay? So, this one is your u-axis, and these are your shearing stress on the u-axis. So, since it's clockwise, nagyapon. No? And on the opposite axis, sigma v is this one, and the shearing stress on these two axes are this, which tends to rotate it counterclockwise. So, naa siya sa ubos. So, it is always the case that if you draw a certain axis here, the opposite should come on the other side, and it has to pass through the center. Okay? So, this is the v-axis. By the way, these are the coordinates, ha? Kining sigma u is from the origin to kana siya, no? And then sigma v is from the origin to kana. And then tau uv is that one, and also this one. However, this will rotate the element clockwise, and this tau uv will rotate the element counterclockwise. Okay, so letter D for the stress of an element oriented phi from the original, no? So this is oriented phi from the original, and then it is in the clockwise direction. So in the clockwise direction, kaning 2 phi on the Moore circle. Now it's always the case that the stresses on the element should fall on the Moore circle. No, walay dire sa sulod. It should always be a point in the circle. Okay? Okay na tana? So, make sure that you understand how to... By the way, remember all the stresses are represented in the Mohr circle if you go around the Mohr circle. Is there a possibility that we can have a compressive, an element oriented in a compressive stress? So you go around the Mohr circle. Is there a possibility that our origin is here? Is there a possibility that we can have a element orientation wherein the stress, the normal stress, one of the normal stress is compressive? So mutuyo ka sa Mohr circle, is there a case wherein you will have a compressive? Remember, compressive stress in direction. So you will never have any compressive stress when the Mohr circle is oriented that way. Do you follow? Huh? Do you follow? Wala may tingog class. Okay. However, if I'm going to draw the Mohr circle, and then this is your normal stress axis. In our case, it is the origin is here. So all the stresses around, normal stresses around the Mohr circle, you will never have a value which is compressive stress. However, if your origin is somewhere here, of course, these points here will represent an element where there are compressive stresses. Or if your origin is here, unsa man ang mga stresses, possible stresses, we're talking of normal stresses. No? Okay, it is on the left side of the origin. So, all your points here are compressive, no? All the points on the Mohr circle represent an element with compressive stress. Okay? So, if it is in the middle, then of course, you will notice that any normal stress in this direction is the same amount here. Kini siya og kana parehas. Kani pod siya og kani parehas. No? If your origin is at the center of the circle. Okay? So, in other words, your element will always have the same sigma x and sigma y. Okay, kana sigma y man na siya, kana sigma x. Kani. For this and this, for example, these 2 points here, and let us say this is your x-axis and that is your y-axis, then ang imong sigma x dere and imong sigma y dere will have the same. O kana, imong sigma x and your sigma x here, sigma y and your sigma x here. Well, by the way, lain na ni, we will not call it anymore x and y axis, probably a different name, no? A axis or B axis, something like that. Okay, class, do you follow? Oh, any question? Any question? This is very important also because this will be the basis of formulas later. No? It will be based on the Moore circle. Okay, so depending on where your origin, no, pwede dire, pwede dire, pwede dire. Or in our case, ang atong origin is here. Kani, no? Pwede po nga ang atong origin na dire. Or there is a certain portion that na portion nga compressive, ang iyang opposite ana should be tensile. Ang in a certain axis, compressive ang imong kuan, no? If this is your tau axis, no? So during a side will have a negative normal stress or compressive stress. Oh. Okay. According to what you have here, the original orientation is along the x and y direction. Of course, horizontal and vertical, x and y. Now, in another orientation, the state of stress of the element, which is oriented at an angle phi. So, atong tuyokon atong element at an angle phi clockwise, that is the meaning of this. How do we determine the stresses on the Moore circle? Okay? So, gikan sa x-axis, rotate mo ta og, rotate ta og 2 phi. You get this coordinates, and those coordinates are your stresses on the element. Pwede pong balihon ako. Main ko nga, this is what is given. Which is, kinesia is kanang oriented at a certain angle from the x-axis. And these are the stresses. So in other words, these are the stresses that are given. Probably the question will be, what will be the stresses on the x and y? So you just reverse the procedure. So you go back, of course, the x and you rotate the element here to have an x and y. So pila man ang angle ana. So pila na siya. Of course, to draw the element, it is easy because x is horizontal and y is vertical. However, on the Moore circle, muna siya ikuti kay dili man, you will not see it here, vertical or horizontal. In fact, the x-axis is at a certain angle because it depends on the coordinates of the stresses. No, coordinates sigma x and tau xy, sigma y and tau xy. So, for this case, we started with the element on the x and y direction. Any more questions?
Excuse me, sir.
Yes, go ahead.
Kanang x-axis sa Moore circle, sir, more inana da jud iyang position daan, sir?
It depends. Remember, this depends on the value of sigma x and tau xy, and sigma y and tau xy. Sorry. Now, the orientation of the x-axis depends on the sigma x and tau xy. Kaya ato man siyang i-plot on the coordinate system. if, did I answer your question?
Yes, sir.
Oh, if for example your sigma x is here, na mo sigma x and tau xy, ana. In the other side, it is here. So ang imong Mohr circle will be this one. So mo na po na imong x-axis and this is your y-axis. How much is this? No, basig ang imong value for sigma x and tau xy are small ang imong tau xy, yeah. Dako ang imong sigma x, so probably like that. That is your sigma x and tau xy. This is your sigma y and tau xy. Did I answer your question? The way we find the orientation of the axis in the Mohr circle depends on the value of the normal and the shear stress. Did I answer your question?
Yes, sir. Thank you, sir.
Next meeting, we will have an example wherein there are values, no? Kaya kini siya murag makakuan ra magyapon mo, murag di pa kayo klaro, no? Because like how much is this? That is your value for sigma x. How much is this? That is your value for sigma y. Sigma y. So probably pila ni 1000 psi and this one is 2000 psi, something like that. And then how many psi are you shearing stress? Okay na tana? Yes. Ano to? Bali, ana ang kuan. For compressive, whether it is in the y or the x direction. If it is in the x direction, ana. If it is in the y direction, ana po. Because it depends on the position of the Mohr circle, huh? Because if your Mohr circle, no, this is your Mohr circle. This is your Mohr circle. This is your Mohr circle, and your origin is somewhere here. And let us say your element oriented here, or probably oriented here. The sigma here is compressive, a tensile. This is the origin, huh? This is tensile. What? Let us say axis A, A axis. Sa B axis, it is compressive. So your element, wala ko kabalo asa unsa orientation sa A o B axis with reference to the x and y. But if, for example, it is something like that, and this is your A axis, A, and this is your B axis, then on the A, this one is tensile. And your B, since your origin is here, is compressive, like that. And then, of course, automatic na, how much is this? Are your sigma x, o tau xy, no? So, kini is the a-axis. Unsa man ang imong kuan? Direction sa kini. A-axis. Mo ni atong a-axis. Mao man ni ang atong, this is our shearing stress on the a-axis. Unsa man ni siya? What direction? So, and of course, on the other side, since it is below, automatic yun na siya. It's always automatic that it is below because the axis will always cross the mutabok na siya on the other side. Did you get my illustration? Class, did you get my illustration? Any question, class? Any question so far? Okay, let's continue with the principal stress. Now, according to the definition of the principal stress, the maximum and minimum value of normal stress are called principal stress. Okay, so remember that you plot the orientation of the element on the Mohr circle, no? Dili kaysa diri sa sulod. So meaning if you are here, the opposite is here. If you are here, then the opposite is here. And as you go around the Mohr circle, your stresses will vary. If you are from here, if you move here, you expect that your normal stress will be bigger than you are here. Okay? Now, going back to this definition of principal stress. Where is the location of the principal stress in the Mohr circle? Meaning, it is at the orientation where the normal stress are maximum and minimum. Where is it oriented on the Mohr circle, or at what location is it on the Mohr circle? Of course, you have to look at the point where the maximum normal stress occurs. Asa man? What do you mean x-axis? Oh, remember this is now the sigma x, or the tau axis, and this is the sigma axis. Okay, so it's asaman. Okay, it lies on the sigma axis, where this one and this one, no? These are the location of the, because you cannot have any other maximum points in the normal stress aside from here. And of course, the minimum will be this one. So that is how we define principal stress. Okay. So let's look at the orientation of the principal stress. Okay, from the x-axis to the, we call it one axis, no? One axis na siya. One axis and two axis. So from x-axis, we move toward the location of the maximum and normal stress, which is, this is now your one axis at this angle from the x-axis. So at this angle, 2 phi man na siya diha, o 2 theta, so theta ra dire. No? So 2 theta dire, theta from the x-axis clockwise. So from the x-axis clockwise to theta. And that is your orientation of your one axis. Kini. And of course, on the opposite side is your two axis, which is this one. And your stresses are sigma 1 for this along the one axis, and you will notice what is the shearing stress here.
Zero, sir.
It is not on top or it's not on the bottom. It's on the axis, so you have 0. 0. Your shearing stress is 0. And also here, your shearing stress is 0. Okay? So 2 theta on the Mohr circle, which is only theta on the element. Okay, any question? I have to go slow, kay Juan, no? I have to go slow. Because you're not able to encounter the Moore circle in your mechanics. Because there are other applications of the Moore circle aside from stresses, no? In mechanics, pero wala man po. So that's why it is a new. In fact, when I was a student, that is also new to me. I only encountered it during machine design. So it is very important how this Moore circle is being set up based on the element, stresses on the element. Okay na ta? No more question on the principal stress? So let's proceed to what are the location now for maximum shear stress? Maximum shear stress. Any suggestion, class? Asa man dapita ang mokor ang maximum shear stress?
H of I, sir.
Okay. So these two are the values of your maximum shearing stress, the H and the I. The difference is that this tau max tends to rotate your element in what direction? Clockwise. While this tau max will tend to rotate your element in a counterclockwise direction. Pero wala man ito. We don't have any sign for clockwise and counterclockwise. So we just have to look at whether it is on top or below the sigma axis or the normal stress axis. Okay. And how is it oriented? Okay, it is now oriented from the x-axis. We'll refer it from the x-axis. We started with the x-axis. So from the x-axis to the axis of, we call it 1 prime, 1 prime and 2 prime for the maximum shear stress. Ang principal stress, which is the maximum normal stress, 1 and 2. For the shearing, 1 prime and 2 prime. Okay, so from the x-axis, the 1 prime axis is towards the what direction? We rotate counterclockwise from the x-axis to locate the 1 prime axis, where the maximum shearing stress is what direction? Clockwise, because it is on top, no? Okay, so let's go to, kita pa? Let's go to the maximum shear stress. Can you see this? Kita pa ninyo nga, kuan?
Dili, sir.
Kanin ka na akong i-point?
Dili na,
Dili
sir.
na,
Dili
sir.
na?
Dili na, sir.
So again, okay, akong i-transfer dito, di naman ano. So again, it is, from the x-axis, it is 2 theta 1 here, 2 theta 1 to the axis of the 1 prime. So in that case, this is your maximum shear stress. From the x-axis, it is theta 1 because 2 theta 1 man na dito sa Moore circle. So theta 1, that is your axis of the 1 prime. And the axis of the 2 prime is still theta 1 from the y-axis. Okay, do you follow? It is in the counterclockwise direction. It is in the counterclockwise direction. So from the y-axis, mo gyapon na siya nga angle to theta 1. No, this is your 2 prime axis. And your stresses here are, of course, sigma 2 prime and sigma 1 prime for the normal stresses, sigma 1 prime and sigma 2 prime, and then tau xy, tau max for the shearing stress. So if we go to the figure of the element, this is your 1 prime, which is theta 1 from the x-axis in the counterclockwise direction, and this is your 2 prime, which is also theta 1 in the counterclockwise direction from the y-axis. And then on the Mohr circle, these are the coordinates, no? Sigma 1 prime and sigma 2 prime and tau max. Okay? Now, okay, going back to this. We are now here. This is our maximum shearing stress. Maximum shearing stress. Okay, so for the maximum shearing stress, these 2 points here, this tau max tends to rotate your element in a clockwise direction, and this tau max tends to rotate your element in the counterclockwise direction. And this is in the 2 prime axis. So in the 2 prime axis, it tends to rotate it in counterclockwise direction. And in the 1 prime axis, it tends to rotate in the counterclockwise. So let's go to the element. Okay, in the 1 prime axis, it tends to rotate it in what?
Clockwise.
Let's go back. Oh, so it is on top of the sigma axis or the normal stress axis. So it tends to rotate. This tau max is this tau max here. Kini nga tau max. And the other tau max, which is on the 2 prime axis, is this one. They have the same. Remember, shearing stress always have equal magnitude. Okay? So, do you follow? Do you follow?
Yes, sir.
Okay. Now, another important part in our analysis is if we can determine the radius and the center of the Mohr circle, then all the rest is easy, no? As long as we are given the angles. No? If we determine what is the center and the radius of the Mohr circle. Okay, so how do we determine the center? Let us base it on the starting point, which is the sigma x and sigma y, and tau xy. So we are here, sigma x, tau xy, and sigma y, tau xy. How do we determine the center? Coordinate of the center of the circle. Center. Now, if you draw this, remember this is sigma y, and this is sigma x. And it is center also of the 2. So how do we determine the midpoint? Di mo kadumdum sa inyong midpoint formula? Sa inyong kuan? Sa inyong midpoint formula. Let us say, kiniraman akong makuan. Ganita. Let us say you have 2 points here. The coordinates of the two points here, x1 and x2. What is, let us say, xm is the midpoint between x1 and x2. xm is equals to what?
1/2.
1 plus x2 over 2.
x1 plus x2
Plus
over
X2
x2.
2.
over 2.
That is the mode point formula. Okay? So, going back to this, the coordinates of the center is sigma x plus sigma y over 2. Then that is your coordinate of your center. However, this is your, and then what is your tau xy? Oh, tau. Of course, it is here, so you have 0. Do you follow? This is now the coordinate of this point C, which is midpoint of sigma x and sigma y. This is the midpoint of sigma x and sigma y. And the shearing stress or the tau has a 0 value. The radius. How do we determine the radius? We will refer it to the original stresses, which are the x and y. Stresses in the element in the x and y. So radius, you can determine it anywhere. But since we start with A and B, so Diaraputano, we will refer it from A and B. What are we going to use? So that we can determine the radius of this. Which is actually this one, or this one? How do we determine the radius? Now we are having this one is forming a right triangle. So any idea if we want to determine the hypotenuse, because this is the hypotenuse of the right triangle? Onsa to? Any suggestion, class? Wala, class?
Distance formula.
Onsa to?
Gamit ang distance formula, sir.
Distance formula. Remember, for a right triangle, we want to, remember, this is your radius, and we have a right triangle here. How do we determine the radius, which is now the hypotenuse of A?
Pythagorean, sir.
Again, dun sa to?
Pythagorean.
Okay.
Pythagorean
So we
theorem,
are
sir.
going to use the Pythagorean theorem, which is actually this one, or we start with this, plus this one, no? Sa itong Pythagorean, this squared plus that squared is equals to this one squared. Or this one is the square root of this squared plus that squared. Makita ninyo kung ikuan? This radius is equals to the square root of this squared plus that squared. Pila man ang that? How much is that? This and that. How much is that? According to the way you plotted it.
Tau xy, sir.
Tau, this one. It is tau xy. So, you already have one side of the triangle known, tau xy. How about the other side of the triangle? This one. So, dili pa kayo siya diretso. But if you try to go back, you are given sigma x and sigma y. And it is half of this. Okay, midpoint man siya. So, how much is this given sigma x and sigma y? The distance between the two, remember? The distance between the two divided by 2. So, unsa man na siya? You have, what is the distance? For example, Let us say x1 and x2. What is the distance from x1 to x2? Distance.
X2 minus X1.
X2 minus x1. For that, this one is the x2 and this is the x1, but we are only interested with this. So it is what? Sigma x minus sigma y over 2.
Divided
Then
by
you
2.
have this. So now, we say that the radius of the Mohr circle is what? Sigma x minus sigma y over 2 squared plus tau xy squared, according to the Pythagorean theorem. So that is how we get this. Radius of the circle, which is from A to C. It depends. It may not be, for example, if what is given is D and you still follow the same coordinates, no? And it will be sigma u minus sigma v plus tau u v squared. Okay, so since we are given the state of stress on the x and the y axis, so we refer to that. Sigma x minus sigma y over 2 squared plus tau xy. Okay, so next is the formulas on how to compute the principal stresses and the maximum shear. Okay, according to the Mohr circle, can we determine this? We already know the two, center and radius. Can we determine this sigma 1? Sigma 1, by the way, is this one. That is sigma 1. Given what we already know. Okay, your center, the sigma coordinate of center plus the radius. That is your, so your center is this one. The coordinate of this is this one, no? Except the 0. Ang 0 is for the, so this one, the sigma 1 is this one plus your radius. And how about this? Okay, so center minus radius. So that is for the principal stresses. So for principal stress, center plus radius, center minus radius. How about the angle? Okay, the angle here. Let's go back. What is the angle? Which is theta. This is the angle here, no? 2 theta on the Mohr circle, but theta only in the element. What is the angle of the one axis to the x-axis? Where one axis is the axis of the principal stress. It is 2 phi. We already know the triangle. What is 2 phi? Since this is now in the triangle, what is 2 phi? This is the right triangle. Kanino? This is the right triangle. We are x, and this is, we are now principal stress here. How do we determine the angle? This is the angle between the x and the one axis. Given the triangle, di mo kabalo?
Tan, sir. Opposite over adjacent.
How do we find the value of the angle? How sure are you that you are plotting this on 60 degrees? Probably, gamay ra kay irog diha dili na 60. Because we do not have any values. We do not have any values for sigma x and sigma y and tau xy. If we use sine, what is that?
Hypotenuse over.
Hypotenuse? Sine?
Oh, opposite over hypotenuse, sir.
Opposite over hypotenuse for this one. It is opposite over hypotenuse. It is easier because the problem with the radius is it is a more complicated formula. So we'll not use the radius, but the sides. No? We'll use the sides. How do we determine the 2 theta based on the sides? Kaya ang sides is, this is sigma x minus sigma y over 2, and this is tau xy.
Gamitag tan, sir.
Tangent. So what is tangent of 2 theta? Tangent 2 theta is what? According to our drawing here. Opposite over adjacent. So according to what we have there. Tau xy over what is this? Sigma x minus sigma y over 2. So that is tangent to theta. Do you follow? Class, do you follow? Huh? Class, are you following?
Yes, sir.
The tangent of this one, we are analyzing this triangle. The tangent of this 2 theta is this side over that side, and this side is tau xy, and this side is sigma x minus sigma y over 2. So are you following? Okay. So we already have, okay na ni, ang angle. Tangent of 2 theta is, sa to, tau xy over sigma x minus sigma y over 2, which is this one. Okay na nga siya. Are you following, class?
Yes, sir.
Yes, sir.
Okay. Sige. So I'm writing it in simpler terms, no? So kana na lang. Now let's go to the maximum, the location of at an orientation, the element at an orientation of maximum shear stress. So we'll go back to the Mohr circle. We know that it is here. And how much is the maximum shear stress, tau max? Equals to the radius. Okay. So the maximum shear stress, tau max, is equals to the radius, which is sigma x minus sigma y over 2 squared plus tau xy. How about the value of the sigma 1 prime and the sigma 2 prime? Remember, kinesia, this is your sigma 1 prime and this is your sigma 2 prime. And it is this one, that is your sigma 2 prime, and this one is your sigma 1 prime. This is, of course, vertical. So, unsa man? Any idea?
Sir.
Unsa man?
equal lang kan sir ang sigma prime 1 o prime 2.
Yes, they are equal because this is vertical. How about the value?
Ang value makuha ang formula kay kanang sigma x plus sigma y over 2.
Again. So it is what? The center. No?
Yes sir.
Okay, so sigma 1 prime and sigma 2 prime are sigma x plus sigma y over 2. And they are equal. So that will be your normal stress when your element is oriented at maximum shear stress. How about the angle? Okay, let's go back. So the angle again is referring from the x-axis in that direction, no? So how much is this angle? We are now, just like the first before, we are going to use the relationship of tangent. And what is that? What triangle does it belong? Right triangle, pero asa man ana? There is a kuan. So it is supposed to be this one. But this triangle is also similar to this triangle. So if we want to determine this, 2 theta 1, it is the arc tangent of what? Of this one over this one. Or this one over that one. So it is the reciprocal of the first one. Because the tangent of the 2 theta is this one over that. Okay? Do you follow, class?
Yes, sir.
This angle is this one, huh? So, the arc tangent of 2 theta 1 is reciprocal of this. No more question or no more problem. I'll try to test you if whether you can analyze the Moore circle. Any question, any problem or any question? Wala na question, class? No more question?
No more, sir.
Wala na? So, akong usbo na akong more circle so that I'm going to draw a more circle just to test you. Okay, now for this case, our origin is here, no? Now let us say we move our origin somewhere here. Mana itong origin? Center ni sa circle, dili. Sorry. Yan na itong origin. And if, for example, when I plot the points on the Moore circle, it is this one. These two. Remember, opposite mo na sila. What should be the, let us say this is axis A and axis B. Or just to make it simpler, X and Y na lang. This is X axis and this is Y axis. And of course, this is the value of sigma X and that's the value of sigma Y. Your element will look something like this. Of course, that is your X and this is your Y. How about the stresses? On the X,
Clockwise ng X-ray.
X is tensile. And it has a bigger value, no? Compared to this one. We call it sigma X probably here. How about the Y? So along the Y.
Compressive, sir.
So it is small, no? Mayroon siya. That amount. Sigma Y. How about this shearing stress here?
Clockwise, sir.
Clockwise.
Oh, so it's in top. So it should be that way. And of course, automatic na siya nga diri ana. Pikas kay adto man counter man dito pikas. It's always on top for shearing stress on top and the pair is on the bottom. Now, if for example, I'm going to rotate, let us say I'm going to rotate at another orientation. Mas gamay man yung angle, ana, no? Let us say this angle here is to alpha. Of course, this angle here is also to alpha. So from the X and the Y axis, where will you go? This is your x-axis, so probably this is your, unsa man siya nga axis? A, and this is your B. A axis, and this is your B axis. This is your X, and this is your Y. So from the X axis, where will you rotate to get A axis? Counterclockwise, no? Which is only, on the element, it should only be, the angle is what?
Alpha.
Only alpha, because remember, it is doubled on the Mohr circle. So probably tunga rani. So something like that. And of course, perpendicular man siya B. So this is your A, and this is your B. So your element will be something like this. Next, what are the normal stresses? On this direction. Sorry. Kini siya mo A. Sorry, I'm confused now. A, kini siya mo B. Remember, it is 90 on the 180 on the no? So on the A axis, what is your normal stress?
Tensile, sir.
Sir.
Oh. Compressive. Oh.
This coincide with the
Compressive ng A, sir.
tau. This is our This is our axis. It coincides with the axis, huh?
Yun na, sir. A.
What is the normal stress here? Okay, so in your drawing, we do not have any stress. How about here?
Tensile, sir.
Tensile on B. So you will have a tensile stress on the B axis. How about the shearing stress? On the A axis, the shearing stress on the A axis.
Clockwise, sir.
It is clockwise because it is on top. So, and of course, automatic na sa PCAS, no? They should oppose. So that is how we plot this. Now, for example, I have this element, and the and the stress is only this one. How am I going to plot it on the Mohr circle? Oh, by the way, how is the orientation of the tau axis? If that is your element. There are only Nana? At what point in the circle will have only tensile stress? Naaman dire, duha man ka tensile stress dire. Dire po duha ka tensile stress. All of these are in tensile, di ba? So if you have one axis na tensile stress, then the other axis also have a tensile stress. At what orientation is your where is the location of your sigma o tau axis or its hearing stress axis? Dire ba siya? Dire, dili, pwede. Tangent. When you say tangent, okay, dire. Okay, if it is here,
Do sa circle, sir.
tangent to the circle, at this location, you will only have what stresses? Okay, 0 stresses. That represents this one. No shearing and no normal stress. How about the other side? So it is this side. And it is this one. On this side, it is this one. And on this side, it is this. This one is easy, no? Mohr circle. This Mohr circle is easy because the center is equal to the radius, which is 1/2 of that. Okay, that is, this value is this one. And 1/2 of that is the radius, and the center is also the radius. How about this? How do we orient the How do we orient the tau axis?
Nasa center sa circle, sir.
Okay, it passes through the center of the circle because this and this do not have any
Stresses.
normal stress.
Yeah, pure
So
shear.
this one is this axis and this one is this axis. If it is like this,
Nasa left side, sir.
nadere?
Pikas, sir, pikas.
Okay, sa pikas. Because at this point, you do not have any shearing and normal stress, which is this one, that axis. And at this point, you only have
Compressive.
compressive stress, which is this one. There is no shearing stress. So, okay. So, those are the basic things that you have to know about the Mohr circle. So, next week, we will have an example, no, with values, no, for the Mohr circle. Okay, so you now take your screenshot. Okay, now are you done with your screenshot?
Yes, sir.
We'll go to the other side. Come on na, okay na to yung picture?
Mr. Pwede pabalik sa first word, sir.
Okay, sige. Ato sa humano ni. Okay naman eh? Is everybody done with this board?
Yes, sir.
Are you done?
Yes, sir.
Yes, sir.
Okay, sige. So, those who are through, can you turn on your cameras again? Okay, turn on your cameras, please. Okay, are we done? I'm going to ask you to, those who are in class, no? In the room, I'm going to ask you to erase the board. Okay. Ako rang abrihan ni kay pagtaktak sa kuan dust. Okay, class. So we're done. Thank you for a successful class, which is now a hybrid of those who are lucky, but probably as of now, you're lucky to be having a class face-to-face. Only a few, five selected persons, and then, of course, the rest are in online. Okay, so we're still successful. Okay, so that will be all now for this afternoon class. Okay, if you have any question regarding the previous topics, no, you can always ask anytime. Okay na ta? No?
Okay,
So,
sir.
bye.
Thank you, sir.
Bye, class.
Thank you,
Okay.
sir.
You're welcome.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Bye, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.